Welcome to Astronomy Daily, your daily dose of the latest space and astronomy news. I'm Anna.
And I'm Avery. It's Friday, the 17th of July, 2026. And honestly, if you only listen to one episode of this show all month, make it this one.
No pressure then, but Avery's not exaggerating. Today, we're leading with a genuine milestone in the search for life beyond Earth. The first atmosphere ever detected on a rocky, temperate planet sitting in the habitable zone of another star.
We've also got last night's Starship drama. And there was drama, just not the kind anyone had scripted. Plus, the meteorite that smashed through a New Jersey bedroom ceiling and turned out to be carrying the chemical ingredients of life itself.
And later, the earliest evidence yet of a galaxy building itself from the inside out. Some gloriously strange metallic waves on Mars, and as always, we'll close with what to look for in tonight's southern skies. And trust me, tonight you'll actually want to step outside.
Buckle in, let's get into it.
Avery, every so often a result comes along that future textbooks will point back to. This might be one of those. Astronomers have detected an atmosphere around a rocky, temperate planet called LHS 1140b. And that makes it the first rocky world in a habitable zone anywhere beyond our solar system confirmed to have air.
Let's set the scene, because context is everything here. LHS 1140b sits about 48 light-years away, orbiting a small, cool red dwarf star. It's what we call a super-Earth, roughly 5.5 times the mass of our planet, and crucially, it orbits inside the habitable zone. That's the region where temperatures allow liquid water to exist on a planet's surface.
Now, detecting atmospheres on exoplanets isn't new. We've been doing it for more than 2 decades. But until now, essentially every confirmed atmosphere belonged to big, gas-bloated giants, hot Jupiters, planets nothing like our own. Small, rocky planets are so much dimmer and smaller than their stars that teasing out an atmospheric signal has been fiendishly difficult.
Which is what makes this such a big deal. The team, led by Colin Cherubim, who did this work as a PhD student at Harvard, found a signature of helium escaping from the planet's atmosphere. The result has just been published in the journal Science.
Helium might sound like an odd headline gas. Nobody's imagining alien birthday balloons. But it tells us something profound. This planet has held on to an atmosphere despite orbiting a red dwarf. And red dwarfs are famously nasty neighbors. They blast their planets with X-rays and ultraviolet radiation that tends to strip atmospheres entirely.
The modeling suggests LHS 1140b is far enough from its star that it's managed to keep a good chunk of the primordial helium it gathered when it formed. And the researchers think there's more to this world than helium. Its density suggests it's rocky, likely with an iron core, and it probably holds a lot of water too.
And here's the tantalizing bit. If the atmosphere provides even a modest greenhouse effect, and we now know there is an atmosphere, then conditions on this planet could plausibly support liquid water. A rocky planet, an atmosphere, the right temperature. That's the trifecta astrobiologists have been chasing for 30 years.
Now, the discipline. The lead author has been very clear that nobody is claiming this planet has life. What they are claiming, and it's remarkable enough, is the first direct evidence that a rocky, habitable zone planet can hold an atmosphere at all. That's a foundational question answered.
There's also a lovely thought buried in this work. Researchers suspect that the very early Earth might have gone through a phase with a primordial atmosphere a bit like this one. So in studying HLS 1140b, we might be looking at an echo of our own planet's infancy.
Expect a stampede of follow-up observations. Astronomers will want to know what else is in that atmosphere and whether there's water. LHS 1140b just became one of the most important addresses in the galaxy.
48 light-years away, a small world is holding its breath. Well, holding its atmosphere. And for the first time, we can say that with evidence.
From a world with air to a rocket that never left the ground. Regular listeners know we've been tracking Starship Flight 13 all week, and last night was supposed to be the night.
Quick refresher for anyone just joining the arc. Flight 13 is the second outing for Starship's version 3 hardware, and its headline task is deploying 20 real Starlink V3 satellites, actual functioning spacecraft, not the mass simulators of earlier flights.
So Thursday evening Texas time, the countdown ran all the way down. The Raptor engines on the Super Heavy booster began igniting, and then everything stopped. Several engines failed to start, and the vehicle's automated systems triggered a launch abort at T0.
Which, let's be clear, is the system doing exactly what it's designed to do. An abort at ignition is undramatic by design. The vehicle is safe, the pad is safe, and everyone gets to try again.
Elon Musk weighed in shortly afterwards, confirming that some engines didn't start and the automatic abort kicked in. And the fix is already defined. 2 Raptor engines will be removed and replaced, with the most likely new launch window early next week.
And it's worth remembering the stakes riding on this one. The FAA only closed out its Flight 12 mishap investigation last week. That flight lost the booster during its landing burn and dropped an engine on ascent. Flight 13 carries the fixes for all of that, plus that first real payload deployment.
And the bigger picture, SpaceX has filed plans for a next-generation Starlink constellation of up to 100,000 V3 satellites, a network that only works if Starship becomes a reliable, high-cadence workhorse. Every one of these test flights is a stepping stone toward that, and toward NASA's Artemis lunar landings, which depend on Starship too.
So, a frustrating night at Starbase, but a recoverable one. 2 engines out, 2 engines in, and we go again. We'll bring you the launch, the actual launch, fingers crossed, as soon as it happens. Now for my favorite story of the day. Cast your mind back to the 16th of July, 2024. 2 years ago this week, a daytime fireball streaked across the skies of the U.S. East Coast. A sonic boom rattled New York City, and in the town of Hillsborough, New Jersey, a rock from space punched straight through the roof of a house and into a bedroom.
Imagine coming home to that. A hole in your ceiling and sitting there, among the insulation, a stone reeking of sulfur that was quite recently in interplanetary space.
And here's where the homeowner becomes the hero of the story. Rather than putting it on the mantelpiece, they acted fast, gathering the fragments, sealing them in glass jars, and quickly contacting the American Meteor Society. That speed mattered enormously because meteorites start reacting with Earth's moist atmosphere the moment they land.
2 years of laboratory work later, the results have just been published in Science Advances, and the Hillsborough meteorite has turned out to be a genuine treasure. It's a carbonaceous chondrite, the carbon-rich family of meteorites that preserves primitive material from before the planets even finished forming, more than 4.5 billion years old.
But it gets rarer. CM-type meteorites are usually classed as CM1 or CM2, depending on how much ancient water altered them while they were still part of their parent asteroid. Hillsborough sits right in between, a CM1/2, and it's only the second meteorite of that intermediate type ever seen falling to Earth. Thanks to that quick-thinking homeowner, it's the most pristine example we have.
And the chemistry inside is the real prize. The analysis found amino acids, the building blocks of proteins, along with carboxylic acids and a whole inventory of organic compounds. Researchers at NASA Goddard's Astrobiology Lab concluded these molecules likely formed inside the parent asteroid, helped along by briny, salty fluids.
Salty is the operative word. The team found tiny salt-rich fragments suggesting this rock came from near the surface of its parent asteroid, where liquid water evaporated and concentrated salts, essentially an asteroid with brine deposits. They're now comparing those salts directly with the samples returned from asteroids Ryugu and Bennu.
And the big picture takeaway, this strengthens the idea that meteorites just like this one delivered organic molecules, the raw ingredients for life's chemistry, to the early Earth. The stuff of biology, arriving by special delivery.
Fragments are now being curated at the American Museum of Natural History in New York City. And one of the scientists made the point that if a meteorite ever visits your house, you're not unlucky. You've been handed a treasure. Though maybe check your roof insurance policy all the same.
Yesterday, we looked at how supermassive black holes feed themselves. Today, a related question from the other direction. How do galaxies build their centers in the first place? Astronomers at Durham University have just found the earliest example of that construction in action.
Using the James Webb Space Telescope, the Durham-led team studied a galaxy as it appeared more than 9 billion years ago, when the universe was well under half its current age. And at its center, they found something never before seen at that distance, a nuclear disk.
A nuclear disk being, and I love that astronomy makes it sound more alarming than it is, a compact, dense, rotating disk of stars right at a galaxy's core. They're common in mature galaxies near us today, but nobody had ever caught one this far back in cosmic history.
And this one is busy. It's compact, rich in young stars, and showing all the signs of organized, orderly growth. The galaxy also hosts a long stellar bar, one of those elongated structures of stars that rotate as a single unit, which is thought to funnel gas inward and feed the disk's construction. The paper is out in the monthly notices of the Royal Astronomical Society.
The lead author, Zoe LeCount, called it a remarkable and unexpected find, one that will push astronomers to rethink galaxy evolution and the role of stellar bars in the early universe. It's another entry in what's becoming Webb's signature discovery, mature-looking galaxies showing up far earlier than anyone predicted.
And there's a black hole connection here, too. Nuclear disks are believed to act as reservoirs, storing gas that can eventually spiral down to feed a galaxy's central supermassive black hole. So finding one 9 billion years back may help explain how black holes bulked up during the universe's most hyperactive era.
The team's next step is follow-up observations to map how the stars and gas actually move within this distant galaxy. Watch this space, quite literally.
Next up, time for something purely, gloriously visual. The European Space Agency has released a new image from its veteran Mars Express orbiter, and it shows what looks for all the world like an ocean of frozen metal on the red planet.
The scene is Kaiser Crater, a huge impact basin about 180 kilometers across and a couple of kilometers deep, sitting in Noachius Terra, one of the oldest, most battered landscapes on Mars, pummeled by impacts for the past 4 billion years.
And across the crater floor, waves, dark, sinuous, almost shiny ridges that genuinely look carved from polished metal. They're sand dunes, enormous ones, some towering more than 100 meters above the surrounding terrain. That's a dune taller than a 30-story building.
The metallic sheen has a lovely explanation. Bright frost deposits clinging to the dune's south-facing slopes, catching the light. Dark volcanic sand below, glittering frost on top. Mars doing its best impression of a sculpture garden.
The winds in this region blow predominantly from the west, herding the sand into those distinctive crests, some standing alone, others merging into a continuous dune field stretching for kilometers. It's a reminder that Mars is not a static museum piece. It's a working, windy world where landscapes are still being shaped today.
The image comes from the orbiter's high-resolution stereo camera, captured last October and released this week. Mars Express, remember, has been at Mars since 2003, 23 years of service and still sending back postcards like this. We'll pop the link in the show notes. It's worth a proper look on a big screen. And so to the skies above us, and tonight's Southern Hemisphere friends, you get the good stuff without even staying up late.
Head out just after sunset and look to the western sky. There you'll find a beautifully thin crescent moon, only a few days past new, hanging near brilliant Venus, with the bright star Regulus, the heart of Leo the lion, completing the trio.
This is the meeting we flagged earlier in the week, and tonight's the night. A crescent moon and Venus together in twilight is one of the most photogenic sights in all of skywatching. No telescope required, though binoculars will show you Earthshine glowing softly on the moon's night side.
And because the moon is still such a slim crescent, dark sky conditions continue this weekend. From southern latitudes, the Milky Way core is riding gloriously high in the evening. Sagittarius and Scorpius overhead, dust lanes and star clouds on full display. If you can get away from city lights, this is prime time.
One diary note before we go.
Exactly 1 month from now, on the 12th of August, a total solar eclipse sweeps across the Arctic, Greenland, Iceland, and northern Spain. It's a northern hemisphere show this time. But if you're one of our listeners traveling for it, safe journeys, pack your eclipse glasses, and we want a full report.
Jealous of the eclipse chasers. But tonight's Moon-Venus pairing is our consolation prize, and it's a lovely one.
And that's Astronomy Daily for Friday, the 17th of July. A first atmosphere on a habitable zone rocky world, Starship stopped at 0, a bedroom meteorite carrying life's ingredients, a galaxy growing up fast, metal waves on Mars, and a date with the Moon and Venus tonight.
Not a bad Friday. For all of today's stories and links, head to astronomydaily.io and find us everywhere as at Astro Daily Pod. If today's lead story gave you goosebumps, share the episode with someone who needs goosebumps too.
The weekend news wrap is tomorrow, and if a certain rocket flies early next week, you know where to hear about it first. Until then, I'm Avery.
And I'm Anna. Thanks for listening. And as always,
Clear skies.